Alright, welcome to multiplication of integers. So today our learning goal is by the end of this lesson I'll be able to multiply combinations of positive and negative integers, and we'll be using a couple of different techniques to get that done. So let's get started. So the first thing is multiplication is a shortcut for repetitive addition. That's really important to understand that. It's a shortcut for repetitive addition. So if you look here, there are 5 4s that are being multiplied together. So we could write that as 5 times 4. We could write that with brackets. We could also change the order. We could say that's 4 times 5. And in the end, all of this is worth 20. Okay, so it's a shortcut for repetitive addition. So multiplication is frequently represented using an area model. Now you may have a different name from this. Some people call it an array, some people call it a magic box. It doesn't really matter. So what we're doing is we're representing 3 times 2. So you can see we can express this as 3 groups of 2 or 2 groups of 3. So if you're looking at this one here, 3 groups of 2, you're looking at this direction in your area model. If you're looking at 3 plus 3 or 2 groups of 3, you're looking at the picture this way. Okay, and it doesn't really matter which one you use, you're going to get the same answer. And the answer here, of course, is 6. Okay, but what we want to see is that there are dimensions. This is a 2, this is a 3, and when you count the number of squares inside, the area inside that rectangle is the product of 2 times 3. Okay, that's why it's called an area model. So if we look at something like this, 8 times 3 can be represented by the following. So we have 8 along this direction and 3 along this direction. Now worst case scenario, you could draw a picture like this and you could count the number of blocks. It's not the fastest method, but it would work. We could also see this 8 times 3 as 3 groups of 8, and if we're really strong with our addition facts, then we could come up with the answer pretty quickly. We could also see this as several groups or 8 groups of 3, and if we can count on our fingers, do other things, we could come up with the answer. Okay, so if we look here, we should see that there are 24 squares, and whether you're comfortable with 3 groups of 8 or 8 groups of 3, it doesn't matter, you'll get the same answer. Okay, so I'd like you to take a minute, pause the video, and I'd like you to multiply 6 by 13, please. You can use any method you're most comfortable with, just no calculator, so anything you like. Okay, welcome back. So I'm going to do this 3 ways, and you're going to see some similarities in all of them. So the first way I'm going to do this is with an area model. And one of the reasons we really like the area model is that it allows the user to break the numbers up how they wish. So something like 6 times 13, you could break that up as 5 plus 1, 10 plus 3. That would work. You could do this as 6 on one side and a 10 plus 3. You could do this a whole bunch of different ways. It lets the user be the person in control of the numbers you have to multiply. So if we do this now, and then we're just going to cut this up into little squares so we look like the area model. Okay, now it's not to scale because 5 times 10, which is this first block right here, would be 50. 5 times 3 is 15. That would be this block. 1 times 10 is the bottom left here, and 1 times 3. And those pieces, when we add them all together, would give me the result, or the product of 6 times 13. So 50 plus 10 more is 60, plus 10 more is 70, plus 5 more is 75, plus 3 more is 78. Okay, so there's one method of multiplying 6 times 13. I'm sure you have others, so let's take a look. Method 2, this is sometimes called the traditional or algorithm. If I don't show your method here, don't panic. It's just these are the ones I focus on because they're usually the most helpful. Something like this, 6 times 3, so if I multiply those two terms together, I get an 18, and then the next line it would be 6 times 10. Okay, and I would get 60. And then again, I would add those two numbers together and I would get my 78. Okay, now the traditional model, or the algorithm model, I should say, looks something like this. People write 6 times 3 and they write the 18 that way. Okay, so they keep track of the group of tens by putting as a placeholder on top, and then it's 6 times 1, so they're multiplying these two together here. Okay, so 6 times 1. Get my eraser out here. When it's really a 6 times 10, so it's 6 times 10 plus one more group of 10. We just don't tend to say it like that because it gets to be a bit wordy. Okay, and then the next one would be 70. Okay, and we would add those together and we would have 78. Okay, so there's some things you'll start to notice here. There's 60, 18, 8, and 70. If you look at those numbers, you'll have seen some of them right here. There's the 60, 50 and 10, 15 and 3, there's the 18. Okay, so all of these are actually doing the same thing. Okay, they're just organizing the information in a slightly different method. Okay, and they'll all have value. The area model we'll use with our expressions in algebra terms. So this is really an important method to learn how to use, and I'm going to encourage you to try it. And then this algorithm method here is also very powerful when we get to something with decimals. Okay, so if you want to pause it and try, let's multiply 12 times 15. Break it down any way you like and give it a shot. Okay, welcome back. So you might do something like this. 5 plus 5 plus 5. If your multiplication facts are really good with 5, then you can take advantage of that. 5 plus 5 plus 2, that would be the 12 on the left side. And this is the 15 up here. Now, the advantage of making these numbers the same is that there's a lot of repetition. So 5 times 5 is 25, and you would have 3 of them. Okay, you come down a line, there's another 3 of them. So you've only made one calculation, and you've managed to fill in 6 out of the 9 spots. 2 times 5 is 10, and you filled in the last 3. Now all we have to do is add that all up. So we might be able to say, hey, look, 4 groups of 25, that's 100. 2 groups of 25, that's a 50. And 3 groups of 10, that's a 30. So we have 100 plus 50 plus 30, that's 180. And again, if you have a different method, that's okay. This is just trying to introduce this concept. Okay, so if you try this again now, say you want to use different numbers, your facts are a little stronger, you might break it down into larger numbers. Say 10 plus 5 and 10 plus 2. So 10 times 10 is 100, 10 times 5 is 50, 2 times 10 is 20, 2 times 5 is 10, and if we add them up, 100, 150, 170, 180, I get the exact same answer. Okay, so the advantage of that area model is that you, the solver, the user, get to choose what numbers to work with. Okay, so take a minute, pause the video. I'm giving you some big numbers here. 26 times 72, break it down any way you like, and let's see what you come up with. Okay, welcome back. So let's see what kind of numbers we want to do here. So maybe we do a 50, a 20, and a 2. That's okay. And then maybe we do a 20 plus 6. Okay, I have somewhat limited board space, so I might approach this a little bit differently than you. Okay, but if you want to break them down into 10s, if you want to break them down into 5s, you do it whatever you like. Okay, so now my multiplication facts are usually pretty good, but sometimes we get a little bit off. But let's say 50 times 20. So 50 times 2 is 100. So I'm going to scale that up by a factor of 10. So 50 times 20 is 1,000. 20 times 20, that's 400. And 20 times 2 is 40. Okay, 6 times 50 is 300. 6 times 20, 120. And 6 times 2 is 12. Okay, now if we add all of those up, and there's lots of different ways you could add across the bar down these columns here. You could do that. There's lots of different ways to start adding these up. 1,000, 1,400, 1,700. And this guy, 1,820. Now I may have to write that down, and that's totally okay. So there's the circled ones. And then 40 and 12 is another 52. And we have 1,872 is our answer. Okay, so if you got a different value, check your numbers, break it down even smaller, see what happens. Okay, so does the order of multiplication matter? So if we look at 2 times 3 is 6, 3 times 2 is 6. Okay, so it doesn't look like it matters for 2 terms, but what if we have more than that? What if we have 3 terms? Okay, so if we look at the first one, 2 times 3 is 6, 6 times 4 is 24. Okay, that didn't seem to, there's one answer. So now 4 times 2 is 8, 8 times 3 is 24. Okay, and you can probably see where this is going. 3 times 4 is 12, 12 times 2 is 24. So does the order of multiplication matter? No. No, it does not. As long as they're all multiplied, then you will get the same answer no matter what order you put them in. Okay, now I like to prove a bunch of these ideas here with patterns. So just take a look here and watch what's going on. Okay, you don't have to write it down. So now I'm going to go look at using positive and negative values with multiplication and division. And it's one of the few ways I've found to explain this multiplication of positives and negatives that I really like. So 3 times 5 is 15, 3 times 4 is 12, then we have 9, 6, 3, and 0. Now what's important here is to notice that these are going down by 3. Okay, you'll also notice that this column right here is going down. So if we were to follow this pattern, that means the next entry here has to go down by 3. Well, 0 minus 3, or going down by 3, leaves me with a negative 3 here. If I go down another 3, my next entry is negative 6. And if we take a look at the values that create that, 3 times negative 1, well, 3 times 1 is 3, and you'll notice that 3 times negative 1 is just negative 3. So there's some patterns and things we want to learn about multiplying positives by negatives. Okay, and we're going to spend a little bit more time with that. Okay, so if I ask you, what does the following mean? 3 times negative 1. Well, let's do this. It means I have 3 groups of negative 1. So, and if you remember, multiplication is a shortcut for repetitive addition. So 3 groups of negative 1, this would become a negative 3 is my answer. Okay. What does the following mean? 8 times negative 2. Well, that's 8 groups of negative 2. So again, if you look at that, I have 8 groups of negative 2 that are all added together. And if we add them all together, we end up with negative 16. Okay, so now some of you might have heard something about a positive and a negative make a negative. We want to make sure we understand why those things happen the way they do, and that's what these patterns and understanding slides are for. So be careful on this one. This is one of the only places I found, or ways I found, that really explains a negative times a negative without having to memorize a bunch of things. Okay, so negative 2 times 5, that's 5 groups of negative 2. So this would be negative 10. 4 times negative 2, that's 4 groups of negative 2. So negative 6, negative 4, negative 2, and 0. Now you can see here, these are all going down, going up by 2. Okay? So if I follow that pattern, that means the next entry has to go up by 2. Well, 0 plus 2 is positive 2. If I add 2 to that value, 2 plus 2 is 4. So what you can see here, if we look at just the numbers, 2 times 1 is 2, and a negative times a negative ends up giving me a positive answer. A negative times a negative ends up giving me a positive answer. Okay, so if you have some ways of remembering that, okay, well, I'll summarize it in a second, but let's just see what this looks like when we get it kind of messy and complicated. Negative 2 times 5, negative 10. Now you'll notice that negative 10 shows up here, and then I'm going to times it by a negative 1. Changes. This would be negative 10. These two multiplied together would give me positive 1. I'm back to a negative 10. This is a negative 10, this is a positive 1, this is a negative 1. Okay? And then if I repeat and go through, and I'm not going to do them all, explaining them all, but we start to see this pattern. Now what you might notice, and this is what we want to try and highlight here, no pun intended, this has one negative sign, this has a negative sign. This has three negative signs. This answer is negative. This has 1, 2, 3, 4, 5 negative signs. This answer is negative. And this one has 7, 3, 4, 5, 6, 7, and the answer is negative. So hopefully what you're starting to see is maybe there's a pattern or a way we can shortcut this. Well, if you have an odd number of negative signs in the expression, the answer is negative. If you have an even number, so all of these guys are even right here, they have an even number of negative signs when we're multiplying or dividing. I should make sure we're clear with that. The answer becomes positive. Okay, so I've summarized it here, and I didn't put the big red box around it I normally would. Okay, so an odd number of negative signs in a multiplication or division problem lead to a negative answer. An even number of negative signs in a multiplication or division problem, so even goes with positive. Okay, so we'll stop there. If you try the task, integer multiplication, you can put some of those skills into work, and let's see how you do. Thanks for tuning in.